Thanks everybody for coming. I'm really excited for this talk that Cervélo is going to do for us. We have a few people here from Cervélo. We have Stu, David, Antoine, Les. Stu and Dave will be doing most of the talking. We also have Sarah Piano, who's here, who just finished Kona. Second American woman. Very exciting. And we also have Andres Stuzoglu from Beyond Aero, who's been working with Cervélo for about 10 years now, I think, in various aspects. So he has a bike shop at Beyond Aero, and I'm going to turn it on over.
All right. Thank you very much. Hi, everybody. Thanks for having us here today. My name is David, and this is Stu, and we're designers from Cervélo. We just got back from Kona, Hawaii. Pretty tough job, but where we launched our new P5X, which is our top-end triathlon-specific bike. And what we want to do today is take you through the design process of that bike and some of the cool features that we have on that project. So to start, we'll take you back 3 years ago when we first started this project. We had our P5 triathlon and TT bike on the market. And for us, that bike was originally designed primarily as a TT bike. Now, has anybody here watched the Tour de France? Yes? So you know, in that circuit of racing, you have a section of the event where you're individually racing bikes on your own, and you're being timed on how fast you do that. But for that rider on the left, you're essentially getting out of the team bus, getting put on your bike, you do your event, you get off the bike, and you're back in the bus kind of thing. On the right, we have Trevor Wertel doing a triathlon. He's one of our pros on the same bike. And you can see the positions are actually quite similar, but the usage is very different. Trevor, he's got to pack his own bike, get it to the event. He's got to carry all his tools and all his food on the bike with him. He doesn't have a team bus at the end of the day. So there's a lot more going on for that rider. And we realized that the P5 was doing these two very different purposes. And we wanted to try and address triathlon specifically. We saw there was a need there. So the goal for this project was essentially design the ultimate triathlon bike. And that's really how we started, a very wide open project goal. So then how did we start?
So trying to start from scratch, we decided data mining was the way to go. We went through studying the rules of triathlon. So there's many federations across the world that have slight changes in the rules depending on where they are. So we wanted to make sure that we knew what we could do with the bike and actually have them be able to race them. We studied triathlon courses across the world. We interviewed retailers, and we also interviewed industry experts. So we went to a few different triathlons, again, globally, trying to capture the essence of triathlon and Ironman across the world. And we took actually 15,000 photos of different riders at all of these races, all at a side view. Some examples we can just fire through. You can see that there was some very unique setups, and each rider is quite different. And some of the things that we've noticed throughout those 15,000 photos, some very unique stuff. So even I'm surprised we didn't see a Google bike in one of these races, but yeah, people like to do these races for charities, which is this gentleman has done. Ironman Nice. The Ironman Nice, one of the most challenging bike course races, and he did it on this bike. So pretty cool. Also lots of storage, so we got some good ideas for that as well. And so from these pictures, we really wanted to use them to develop and capture some objective data, some data that we could use throughout the development process. So again, we took pictures from the side view, so we were able to compare every single picture to all of the others. For instance, we could determine where people stored nutrition and their flat kits on their bikes. So here we have just a list. I don't know if you guys can read that. A bunch of different areas on the bike where people stored bikes, and we tried to determine the percentage of each preferred area for storage. You can just flip it. Yeah. So here's an example of data that we were able to use forward in our development. We discovered that the most common placement for storage, or for nutrition, in this case, was on the front of the top tube. And so that's, development, end result. Okay, next slide. So we also studied those photos along with the interviews of athletes and industry professionals to determine how many bottles people rode with on the race. We found out that you have this graph shows there's actually 8% of people. For those of you who have done triathlon, I know the gentleman said he had done a couple. There's people out there that ride with no bottles, no hydration, which is pretty interesting, but I'm not sure how you feel about that. There was obviously more commonly there was 1 bottle, 33% of people carried out of T1, 2 bottles, 46%, 3 bottles, 12%. So almost 100% of people would carry up to 3 bottles. So that was something we were able to use going forward as a benchmark. We were also able to, this was pretty cool. This is kind of my favorite part of the data analysis. We were able to take these side view photos and calibrate them to basically overlay them and actually measure geometry, fit. So as an example, we could find the C-post, relative C-post height and saddle height and C-post angle, stack and reach of up to of all the riders in our data set. So really good, useful information, real information that we were able to make sure that we catered to in the development. So this gentleman here represents our most common bike setup. He's one of several in his category, but not that many. And what he is an aero bottle between the arms, a bento bag behind the stem, a bag behind the saddle, and a round bottle on the down tube. So those are 4 things that were most commonly used and placed on the bike throughout our analysis. And I got a question for the people in the audience here. How common do you think that most common setup was out of all of the selected photos that we studied? Can anyone guess? 95%? What was that?
I said 20 or less because there's just so many choices.
On the right track, yeah. It was actually less than 4%. Right. So yeah, our senior engineer used to present this part, and he would kick the guy that said 95% out of the room because he was so off. But no, you can stay. I'm nicer. Right. So 3.8% had that setup. So what did that tell us? Oh, sorry. And of all of the setups that we studied, there were 688 unique configurations. And so this was, again, something we wanted to use moving forward. We knew that the bike that we designed for triathlon needed to accommodate a lot of different needs. Nutrition. We wanted to make sure that we had enough nutrition on the bike to support a full Ironman distance. We designated a volume in the top tube area that could hold almost 1,600 calories of nutrition. And of course, 3 bottles that could be filled with added calories. We also know that we need, in race scenarios and training, we also need to bring our flat kit storage. So we designated a certain, this is what we decided that we need to fit on our bike for an Ironman race. So again, after studying users objectively, after speaking to industry professionals and studying courses, we created a scope for the project. And the scope is actually basically 7 main priorities. The first being we needed a modular and integrated design, something that could fit all of those options that people rode with, that wanted to ride with, but with the performance control that we wanted to gain. We wanted to use round bottles, something that we realized was consistent across all the races across the world. We wanted it to be easy to fit, just so that people can stay in their position and really actually stay true to our performance claims and go faster for longer. We wanted it to be easy to adjust. And we wanted it to be easy to adjust after fit. So we wanted it to be easy to pack as well, because of travel being a major proponent to the use cycle. And interestingly enough, our 6th priority was aerodynamics, and our 7th was stiffness. So that's where we started.
So then, again, the question is, how do we start from there? So if you go to the next slide, does anybody know what these are? So this is a set of governing rules and boxes that are applied to UCI regulated bikes. And that applies to any bike that's in the Tour de France or other races like that. And so every frame manufacturer has to fit their bike inside a set of boxes. You can move them around a bit, but they have to be of a certain dimension, and there has to be a tube in every box. So if you look, on the next slide, our P5 is actually very driven in shape by these boxes. So you can see how closely it actually fits to those box shapes and really governs how we created that shape of that bike. In triathlon, it's not governed by UCI regulations, so we do not have that starting point. It's very challenging still to design a fast and efficient and good bike within the UCI rules, but it does give you a place to start. You know there's going to be a tube in every one of those boxes. When we started this bike, we didn't have that starting point. We had a blank piece of paper. And so in some ways that was almost more challenging. The freedom was really nice as a designer, but the challenge is trying to figure out, which one of the ideas to go with. So we needed some starting points, some sources of inspiration to come up with how to make the shape of the bike. So one place that we started is structural analysis. And we used a tool called topology optimization. And what that is it's a computer software algorithm that gives you a sense of where material is really important in a structural volume. So what we did is we created, just go back one. We created this volume of space that's shown there as semi-transparent. And that represents the part of the frame, the part of the space that we can use for frame material that doesn't interfere with all the wheels, the cranks, the rider's legs. And then to that shape, we apply loads that represent riding loads in real life. So, the twisting of the frame due to riding. And then what the software does is it actually takes away material that isn't highly loaded or highly stressed, and it actually removes that material and then reruns the simulation again. And it keeps eating away at material until you're left with just the most essential material to meet that load case. So you can see in this little animation here, you start with a big block shown in blue and actually sort of erodes away at the material, and you're just left with the key bits of material that are most important. And so that gives us a sense of maybe where we should have material on the bike. So you see a very strong connection between the head tube at the front of the bike down to where the cranks are, and then a very low rear end to the back wheel, and then kind of this diagonal member off to the seat. So the question was, how do we address the directionality of using carbon versus a material like aluminum, which is continuous in all directions? So in this case, we're doing, what we found is it's too complicated to try and apply that at the initial stages. So what we do is we do sort of a simple aluminum-like case, and that tells us where the material is important. But we still later have to go and optimize our layup and figure out how we apply the carbon to that. So really, again, it's just a source of inspiration. Like generally, what are we looking for in the frame? In the next slide, you can also see another version of the output where you can actually force it to provide you with a truss structure and see what that would look like. And you can kind of see the essence of maybe a motorcycle frame there in that version. So then how do we turn these into actual designs? So in the next slide, you can see a number of the different directions we were going with the concept. In the top left, we have a frame that's sort of a literal translation of that topology optimization turned into a frame. But then at the same time, we're also looking at parallel development streams where we're saying, okay, well, what if we just want the most aero bike? We see frames there where we're taking a P5 and just adding surfaces to make it more aero. We're seeing other ones there where we're looking at usability of the bottles. Can we drop them in just like a cup holder in a car? We're even looking at compliance and whether that's a good thing or a bad thing. So what we found, though, is we kept running into this issue of where to put the round bottle on the frame. And it actually became more driving to the design than we expected. We have this bottle that we wanted to incorporate into the frame, but we realized that we needed material around it, and we couldn't interfere with the rider's legs. So in the end, we sort of had 3 different approaches to that problem. The first being the material below and behind the bottle, like this. And then the second, sort of going around the bottle on either side. And then the third being in front and above the bottle, which is what you see in front of you. There was a lot of potential in some of the first ones, but we were getting structural challenges with having enough stiffness in those systems. So in the end, we went with this approach, as it gives a good connection from the C-post into the head tube, a good connection from the head tube to the down tube, but also has this nice volume in here that we can use for a bottle or additional storage with a horizontal bottle. So through this process, we wanted to just highlight a few neat tests that we had to do. Quite often we'd have a concern or an idea that came up, and we'd need to quickly test it and not just speculate on how it might work. So there's a few cases here. The first one shows we're testing 2 things here. You may know the sort of IDEO approach, which is rough, right, and rapid for prototyping. And this is kind of an example of that. It's very rough, but it gives us a good test, and we did it very quickly and got a good answer from it. So we're filling in the entire frame because we wanted to test the effect of side area. We knew that we were looking at designs that had more side surface area to them. So we did a number of ride tests with that. And at the same time, we've also got a bottle cut in half and taped to the side of that. And that allows us to move that bottle around in space and find out the highest we can mount a bottle without it interfering with the rider's legs. So we had a number of riders try that. We created this volume for each rider, and now we know where we can put the bottle. This is a test we did where we instrumented an athlete's bike. And so we had power, yaw angle, speed, GPS. But we also had this video on board. And one interesting thing we were able to look at was we could scrub through the video and find out how often he was in the extension position, how often he was in the base bar position. And as we know, being in the extensions is much more aero, and you save a lot of energy being there. So it was an interesting exercise in perception because he was sure he was in it 95% of the time. But when we went to the video, it was a lot closer to 60%. And so we realized that we needed to find out why he was doing that, and also the importance of creating comfort in that position so he could stay there.
We also did some testing for storage, ease of use in terms of the position. And keep in mind, we didn't have an actual. The frame was so unique that we were having to work on all of these tests with P5s. We had cut up our our old P5s and tried to place them in the most accurate position to the new bike, or to our concept at that point, where the storage would be in that concept. So you can see we would cut the top tube right off, lower it down to the place where you'd see it now on the bike frame, and then we'd have people test out the ease of use in terms of at that point we had an idea where we would put storage inside of the frame. We wanted to make sure that people could access it, and that justified things like, which we'll talk about later in terms of the features, but making sure that the top section was relatively pliable so that someone could get their hand in. We also tested the idea of putting a volume down near the BB under the down tube, and we wanted to make sure that we knew how that would affect the ride experience, if it would affect it at all, and also design ideas as to what side the door should go on, or will it make any noise, or things like that. So, and of course we did some when we did get our first frames together. We did some initial product testing with some of our pro athletes. This is Sarah. That's Sarah. And she's kind of smiling in that picture, but she's going pretty fast. So we got some really good feedback from our pros at this stage as well, just making that final tweak, validating that we're ready for production.
Yeah, right from the beginning, Sarah was there in our first interviews, and then right at the end, down to the last development cycle, she's there giving great feedback. So we'll take you through the features of the bike, and I wanted to start with the bottles because that was, again, as I said, a big driving factor. So what we ended up providing, again, round bottles, so that it's very easy to grab and throw away bottles during the race. You're not committed to a fully integrated aero bottle that you don't want to lose. So we got a round bottle between the arms, which is really nice, can be very aero, and sort of reminds you to drink as well. We have a bottle here, positioned horizontally, which is nice for access, but also gives this option for additional storage box. If you don't want that box, or you want a more traditional bottle angle, you can mount it like this on the down tube. Then at the back, we created a single bottle rear mount, which is a very aerodynamic position. And we also provided, it's fully integrated and built into the C-post, so it's very stiff. It also articulates and slides in and out so that you can get the bottle at the angle and the distance that you like.
In terms of top tube storage, so what we designed was a two-part top tube storage system, which we call the Smart Pack. It's got an upper section, which is a rubber material, it's semi-rigid, to hold the form while not in use of the bike, but while in use, you're able to pry it apart and reach down into the second section located inside of the frame. It also has a designated pill tray located in the rear. You can kind of see it in the picture, and some side pockets, just to give people options. A lot of people are pretty unique with their nutrition needs. Some people make their own even, and they pack it a certain way. So we just provided these optional things that you could add in or take out. You can also even run the whole thing with, there's actually a door that blocks off the internal compartment. So if somebody didn't require as much nutrition, they could do that. And alternatively, they could also remove the upper section and just run the in-frame compartment. Okay. So the in-frame storage, actually I can just talk to it. We call that the stealth box, and that's essentially where we've designated the area for our flat kit. It's got an optional internal case, which you can fill with all of the items that we determined in our research, and then you can also remove that back piece and just run the door alone, and essentially pack more items inside of the frame. Things like tubulars, in the case where people will be riding tubulars, or they want to bring a large pump or something, they can put inside the frame and and still have enough space. Sandwiches, Subway sandwiches sometimes. And in those cases where you might need that storage for your whole sandwich, you could put the rest of your flat kit inside of the speed case, which is an optional case as David described. And that's just a same, that's not good. A same, it's a side door loaded plastic case. And so, so these are the storage areas which we've essentially decided on based on that research and our user testing. Essentially trying to provide as many options as possible while controlling our performance and our aesthetic.
So a question that often comes up now that people have seen the bike is, why are we using disc brakes? A big part of that, we really, our road line is going towards disc. We really want to bring that control, that power, and consistency in all weather conditions that you get from disc brakes into the triathlon market. So there's no question there for us that we wanted to do that. At the same time, what's really neat is it opens up new design opportunities for the bike itself. The system is now changing a bit, and so we can change how we design it. So because we don't have a rim brake up at the top of the fork, this area is now much freer in terms of design. So we can clean that up aerodynamically. We can also create a much stiffer front end because there isn't a brake inside there, using up space. And it also helped us achieve our adjustable front end that I'll show in a bit. We're also, the frame is designed or optimized for electronic shifting, which is sort of the way that the components are going these days. It still works with mechanical shifting as well. But what we want to do, a number of the electronic systems, the wiring comes into a junction box. And so one element that we wanted to conceal that, but there's still a rubber window at the top, and then you can see the battery life for that box. And then you can also access it by unclipping the back, and then you can charge it that way as well. So we wanted to sort of conceal that element, but keep it very user-friendly at the same time. So now the front end of the bike, which is probably my favorite part of the system. We really wanted to prioritize the adjustments that we wanted people to be able to make and make after that first fitting, so they could change their fit throughout the season as they got more flexible or got back into that position. So our first priority was the vertical adjustment of the front end, so how high or low your arms are. And we wanted that to be very easy to make. So we said, where else on the frame do we have a really easy vertical adjustment? Well, sorry, the seat post. The seat post. So we have a wedge clamp, which you adjust with a 4mm Allen key, and it slides up and down. So we essentially took that same concept and applied it to the front. So we have, you access it through a hole in the front. There's a 4mm Allen key that you would grab. You would undo the wedge clamp, and then you can adjust that up and down very easily. For those that haven't had a tri-bike in your life before, that's a very unique thing to have, that kind of adjustment. Very often you're sort of committed once you pick your fit to that's where you're going to be. So in the video here, you can see that vertical adjustment as the first priority. And then there's also, fore aft and in-out adjustment of the pads. So you can see it flipping there to get a very large range of pad adjustment. There's width of the pad that you pick by bolting in a different increment. Then the extensions are just clamped cylinders, so they're very easy to pull in and out and trim to the length you want. And then the base bar down here actually can be flipped up or down. And you can see on this frame it's flipped up, and this one it's flipped down. And that gives you a choice at the time of cabling the bike whether you want a high or low base bar.
Want to show them the tilt adjust as well?
Yeah, we didn't mention that in there, but on the P5 we weren't able to pitch up and down because UCI rules say that you have to have horizontal arms. So, but it's quite a nice feature to be able to just tweak that a little bit and sort of lean into the front end. So there's 2 bolts in the top, and you can just dial in that pitch of the front end as you like it. So another feature that you may have noticed if you looked at the bikes is the bars are actually split, and they're made in 2 halves. They're not just flippable, but they're actually 2 halves. And that allows for some neat things when you get to traveling with the bike. And so we'll show that here. We really wanted to create a complete system to help reduce that stress of getting your bike to the race.
Right, so you can see that we did that actually. The idea of creating a bike that was optimized for travel was essentially done from the beginning in our scope, and obviously shown in the collapsible bars. Why else would we do that? And I'll show you in this Bike-End Helium 4 bike bag. Whoops, sorry. We were able to collapse the bars off to the side by removing 4 bolts and a plate. And actually, with the same ease of adjustability of the whole front end, you're able to release it just like a C-post, remove it, pack it in front of the bike. And it's all strapped into place with some custom neoprene foam molded protective padding that we developed alongside of the Canadian bike brand Bike-End to create that full triathlon travel packing solution. So directly related is adjustability, the ease of adjustability and the ease for travel. It's only 6 bolts that you need to access in order to pack the whole bike, and 1 bolt for the rear derailleur. In terms of the bike interaction, it's 1 tool, 4mm tool, can be done in a few minutes. I don't know if there's anyone here. Does anyone have any horror stories for packing their bike?
Yes.
A couple people. So a lot of times, again, adjustability and packing go hand in hand. When the bike is not very easily adjustable, it's likely not very easy to pack. A couple features of this bike bag is it uses a airbag protection on either side, which allows you to, provide that secure fit for all of the parts, and also allows you to pack 2 sets of wheels and still maintain underweight, right? Do we make it through underweight? Yeah. Awesome.
So this is
actually Sarah's bike. This is a world champion bike. Still got the tag on it. Still got the sweat on it, everything. Really trying to, support the full triathlon experience, and this is sort of the icing on the cake with all of the other features that we've tried to bring into the bike. This is sort of that last check. So providing a solution for travel, the full travel experience, two bike wheels, full bike, all together, and no loose parts. So just reducing that stressor in the triathlon racing experience. And that's it for travel.
So manufacturing, we're just going to touch on quickly, but it's actually a pretty key part of this project. We knew that with a design like this, we really had to work with very strong partners, people we could collaborate with. We also knew that there was a concern with IP for the bike because it was such a unique shape. We didn't want it getting out before launch. So we wanted a factory where we were more exclusive and had really strong partners. So we partnered with 2 of the industry leaders in manufacturing, in front-end design as well, and wheels. So the frame is made with Head in Minnesota, and the front end from the head tube forward is made by Envy in Utah. And it's just been a great partnership, and having their expertise to add has really made the project happen the way it has. And then we'll get into the numbers because we always like numbers. So in the end, in terms of the frame stiffness, we've actually improved the head tube stiffness, which is the front end stiffness of the frame. And the BB stiffness is the same as a P5. And we found that those are very positively received. A big part of that is the frame is made in all one piece, one continuous piece, no bond joints in the middle of tubes. So that's really helped us create a very strong system. The other thing we wanted to note is that this is not designed to be a suspension beam kind of ride. This is a stiff frame, and the deflections are very small at the beam. So it's not like some of the older beam bikes you may have seen in the past. And then combined with through axles at the front and this very stiff front end, it's really positive on the road. And then to get into the aerodynamics a bit, if you don't know already, we try and test with a balance between very consistent wind tunnel procedure and representing real life. So we find if we test with live riders, the data is very noisy. So we use what you see here, which is a mannequin in position. It's a mannequin of Dave Zabriskie. And that's how we compare. In this case, we want to compare the bike as it's used in real life, which is in triathlons with stuff on it. So our test that we're presenting primarily for this bike is fully loaded. So we have 3 bottles, we have all the food on it and the tools as well. On the P5, we had to tape on some items to get that full capacity, whereas on the P5X, we're able to contain everything in the frame. So the result is that we met our goal. We're faster than the P5, and on average, 30 grams faster across the 15-degree yaw angle sweep, which is the range of wind angles to the bike, depending on what kind of crosswind you're riding in. So now, video? Okay, we'll take you through, really as you've seen, this is a focus on personalizing your bike, making it for the rider, and it's about the experience with the bike, not the bike on its own, and you'll kind of see that in the video as well. All right, so that's our presentation, but we've got a bit of time for questions, I think.
With the disc brakes, can you use a disc wheel?
Or do you sacrifice that by using
Yes,
disc brakes?
they are starting to make disc wheels with disc brakes, so that is an option for sure.
I just had a question with regards to the vibration damping at the seat. I'm just wondering if with the cantilevered monocoque design, if it's better or worse than the P5 from the rider perspective. Maybe that's a question.
Yeah, that's a really interesting question. I think, Sarah might be able to talk a little bit about how she feels about it, but generally the deflections at the saddle are very small, but there seems to be an effect of less of vibration transfer in terms of road texture kind of feel. And so some people have commented on a comfort aspect, that they feel it's more comfortable. But it's not floating around. It's not like you're changing your leg length by a significant amount. And that's what we wanted to avoid.
Yeah, I mean, when I was riding the bike in the race and beforehand, I mean, one of the things I initially noticed, and I think a lot of us noticed who rode it, was how smooth the ride was and how little vibration that we felt. But also, as he said, being able to maintain that stiffness, which was something that was really important to all of us.
Yeah, given that you showed the UCI box that you needed to conform to that.
Yeah.
So given that, how do you get away with not having the rear triangle and be compliant on the rear stays?
You mean like how are we UCI?
Compliant without having a rear stay?
We're not.
Oh, you're not?
Yeah.
Okay.
Yeah. No, but that's a good question. Like that's our intentional diversion from the UCI. So there's a separate line now for this UCI illegal bike. Yeah.
Sorry, my question was about UCI also. So who is the intended audience for this? I mean, is this for Ironman triathlons or Olympics, or what direction are you going in?
Yeah, definitely triathletes, long distance triathletes, and some Olympic, for sure. But yeah, we're not targeting that TT racer with this bike. That's our P5 would provide that.
Question on how you came up with the final selection of the Y-frame design after you did all the topographic iterations. It showed that it didn't look like the beam style frame was the go-to. Is it strictly for aerodynamics? Did you take into consideration, I guess, the original Cervélo, the green one with the I think
the Baraki?
Yes. Was that one of the considerations from the research back then that went into this?
Yeah, that's an interesting question. So the Baraki was not a driving design inspiration. It was kind of a fun result when we started realizing that, hey, wait, this kind of looks like the first Cervélo, but definitely not a driving factor. Really, it was the storage and the bottle placement that was driving more than anything. When I showed those different configurations for having sort of a seat tube and no top tube, or having the top tube and no seat tube, both those were contenders aerodynamically. And so we were really trying to balance everything at once to come up with this. So this one was helping us structurally versus the other orientation, doing very well aerodynamically, and then also giving us this option for this optional storage volume.
Hey, thanks a lot for the great presentation. I remember you were supposed to release the bike around like 6 months ago.
Yeah.
And when you decided, no, we're going to delay it for 6 months.
Right.
And it's probably like something you can talk openly about, but I'm just curious if like, give us some more color about why did you decide to delay it, and what have you improved since then? Thanks
it's no one big thing in particular. Some people were saying, "Oh, did you decide at the last minute to add disc brakes or something like that?" It wasn't that kind of decision. It was really just making sure that we're at the point where we're happy with the product, getting all those little things right, making sure we're going through all our very stringent tests, and just making sure we had it ready.
And available.
Like on the day of the launch, we had how many bikes? 80 bikes in the stores. So then they could bring them out and have them on display and sell them. And so we really wanted that to be ready as well.
Just
Yeah,
Yeah.
that's very true. Just to add on to it, the travel case, for example, wasn't ready at all. So that's all the details that probably were also missing. You saw that it's a big part of the story. It's an accessory, yet it's a big part of the story. The availability is also key. In the past, we've never launched a bike which is day of launch available for every market globally. So you said 80, but it's 120 all over the world. So that has never happened. That's 80 shops and 120 bikes, which were available on the 4th, and that we continue to make, obviously, in the US. And it's all about details, as you saw. So everything was there, but just to refine everything, And that's why we decided to wait. It was a marketing decision, not engineering. And also probably a marketing mistake to say we are ready when we realize maybe we are not. I'm saying that because I'm in charge of the marketing part.
So I have a question about the front bottle. Basically, the bottle needs to be unmounted to drink, right? But there are bottles with a small tube that you can just drink during. So is it your proposal to have this kind of bottle, or is just a sample and like any bottle can be used?
Good question. So what we wanted was, we didn't want to restrict anybody to a certain type of bottle that you couldn't just toss away while you're riding. So we're showing it with round bottles because that's the lowest stress option. You can grab a bottle, like a Gatorade bottle, generic Gatorade, or like a water bottle, and stick it in and toss that one before you get to the end of the aid station. But at the same time, if you want to run those kind of bottles, then that's great, because if you know maybe you have a mixed drink that you're going to keep there the whole time, then you can choose to do that, and you have that straw, and maybe you can stay more aero when you use that. So we definitely recommend choosing the bottles that you want to use, but we didn't want to design our own bottle that you had to use all the time.
Quick question for you. You said 120 available worldwide. What does your run rate look like, if you can even talk about that? When will the bike be available? Are you going to ship it like this, or will it be frame only? Talk about configuration and actually, how much does it cost?
Okay. It's a very good question. So it's already available, and if you go around here, we are working with Beyond Aero, so it's actually you can already go there. And actually, I think already one purchased one bike. That was 2 days ago or 3 days ago. So how much? So it comes exactly like it is, okay, with those NV wheels, SRAM ETAP, everything except bottle cage. So meaning everything that comes with it, everything, including even this holster. The travel case comes as an accessory. And so like this, again, NV wheels, SRAM ETAP, $15,000 available now. Starting later in December, 1st of December, we'll also have it with Ultegra Di2, head wheels, and rotor crank at $11,000. Okay, so and it doesn't come as a frame set. It comes like this. And the bag is $849.
I wanted to ask a quick question. I don't know if you know, our friends down in Morgan Hill came up with another answer to UCI in their rules as a concept bike. I think you guys did great that you actually made it to market. But they had some funny ideas, like really, really big back wheels. I was wondering if you guys saw the FUCI bike and had any ideas about how they had approached it, whereas you guys had.
Yeah, I mean, for us, it's balancing taking the big risks and making something that we can actually get to market, right? Just like you said. We're always choosing what things we're going to take on. There's a lot of things that are still on the wall in the office. I think I'm happy with sort of the approach, how far we went with it.
Hey, I have a question about the aerodynamic comparison that you did with the P5.
Yeah. Okay.
So I think what you said was that you load this bike fully up just like the average person would load up their bike, and then you loaded up the P5 in the same way. Mm-hmm. But I guess for the faster people, I don't think they load up their bikes just like the average person. They don't tape like 5 things to their front tube and stuff like that, right? So in that case, is the difference still 30 grams or is it less?
Yeah, so we find that it's more distance related, I would say, than speed related. There's definitely some of our pros that have a lot of stuff that they take with them. But what's neat is that we also compared the bikes with nothing on them. So like a very clean, lean setup as you would do like a TT, I guess, even though that's not the intended use. And even in that case, we're just a little bit faster than a P5.
Okay.
So that's kind of neat that it doesn't matter the situation, it's still an aero bike. Yeah.
And just to talk a little bit about that, so for me and an Ironman, I usually carry 5 packages of Cliff Blocks and 5 gels with me because I eat 300 calories an hour. And so on the P5 previously, I had a bento box in the front, an Exlab bento box that I would put stuff into, but I was typically taping 4 or 5 gels onto the top tube here, and then another 2 or 3 gels onto the stem. So in the race on Saturday, I fit all of my nutrition into the box, with the exception of 1 gel, which I put just down my sports bra. So it was a lot more convenient from that perspective, and very accommodating. And so I think, as you were saying, for people who may not be as fast, they might bring like sandwiches with them, and then they can put that in the in the box over there. You're not going to fit the sandwich necessarily, but we still do need to carry quite a bit of nutrition, and it really does accommodate that, even for people who are faster.
I really want to thank David and Stu from the team and everybody else that's here, and if we could give them a big round of applause. And thank you.